Well, good evening, everybody. Welcome to Creative Goo. I'm Harry. I'm your host, and I want to obviously start every session by thanking Gooey Cube for sponsoring this stream. If you're not familiar with Gooey Cube, you should check them out at gooeycube.com or join us on Facebook. Let me show you guys the Facebook page if you want to join us, and let me jump to that real quick. So it's Facebook, the Gooey Cube, the Gooey Game Masters Den of Enlightenment. So they made that really long. So um, just keep that in mind. Come see us there. There's always great conversations. Someone, is just today asking about D&D and Druids. Lots of creative stuff there, ideas, posting photos of fancy places in the world and all that stuff. So come check it out. We'd love to have you join the community. Hey, Blood Mist Axe, Ladyhawk, Feldari, welcome. 491 Phantom, you were the first person to jump in. So hello. Let me get back to my intro screen. Just to remind everybody, I'm also on Facebook at Harry's 3D Sculpting. That's where I post all my work in progress, new sculpts that I've done. I also showcase what I've painted so you can see the miniatures that I've sculpted in physical form. I'm actually going to show you guys one today on the stream. So I'm looking forward to that. And you can also find my miniatures if you have a 3D printer at my mini factory. Look for Harry's 3D Sculpting there, and you'll find me there, and I can show you that my mini factory here as well. Let me get that going here. And this is my mini factory. There we go. And so there's this patron option called a tribe. Love to have you join me. And you'll get miniatures every month and a discount in the store. There's also 102 miniatures available in the store at the moment, including the Troll Ruffian that I'm going to show today as part of the 3D printing process. So stay tuned for more. I'd love to have you guys continue with me. All right. So today's episode, we're going to talk about 3D printing. I know many of you have been just waiting and patiently holding your hands and hoping I'll cover 3D printing in detail. Today's that day. We're going to spend an hour or so talking about 3D printing, my experience with 3D printing. I'll show you some photos, some video I recorded of the process you go through, and I'm going to show you some software today too. So there's a lot of stuff going on. And remember, I'm monitoring chat. So if you have any questions, make sure you ask them, because I'd love to have you join me with questions. And so just keep that in mind as we go forward. So everybody ready to hear all I know about 3D printing? Don't everybody speak up at once. I guess you're a captive audience. You can't really tell me no, but we'll just keep going. All right. So 3D printing. So 3D printing is additive manufacturing. What that means is you're building something from material and you're adding to it and adding to it and adding to it till you reach a finished product, versus something like a CNC machine, which is actually carving into the material to remove material. So that's subtractive manufacturing. So additive manufacturing has a lot of different flavors. For us hobbyists and prosumers, there's a couple of different kinds of printers we all use. The first one is called an FDM printer, and they're available from lots of different companies. But I can show you this Anycubic Cobra and the Cobra Max. They are, like you can see on the screen as it's refreshing, They are filament based. Yeah, and it keeps wanting to go through ads. So let me jump to 3D printers and let's look at FDM printers so I can show you. So here you go. So basically, what it's doing is it's pulling effectively plastic. PLA is usually the most common. You can use ABS. There's lots of materials you can pull through it, but it's on a spool, and it pulls it through a heated end, and that nozzle will have different sizes, and it will go and print on the bed starting at the bottom, and it'll slowly add layer by layer until you have a finished model. This was the one that most home people bought first, and the technology keeps improving. One of the things you'll learn about 3D printers is every year there's new technology. They can make the printers faster, they can add new technology, and they can sometimes make it cheaper. And so some of these printers, like this basic printer, the Cobra Neo, right here on this site is $189. It's really becoming affordable for people to join the hobby. Remember, I've told everybody before, this is a hobby. And so you have to really understand your printer that you buy. There's settings you have to understand. There's tweaking you have to do. You have to understand the different kinds of filament on these spools and what their properties are. Like I most commonly print in PLA, which is a kind of plastic. It's been recycled, and it does not like dry weather. It likes to have a little bit of humidity, but not too much humidity. So if it gets too much humidity, then you get different problems with it. And if it gets too dry, it gets brittle and it breaks, and your printer will fail. And so you have to understand all that. So you put it in the right kind of environment, and you have the settings right, and you're storing your material in a way that'll keep the life as long as possible. Like I haven't done any printing in a while, so I haven't even opened up the packaging of my material because I want to store it in that vacuum packed container. And I can maybe have an FDM specific session in the future because there's just so much to talk about. But that's what this is. Let me show you a picture of a print from an FDM printer. So this is all printed and painted, but I wanted to show you one of the reasons that I don't use it for miniatures, right? So this is a bust of a sculpt I did quite a few years ago. You might recognize the character or you might not, but you can see, you can actually should be able to see my mouse. There's lines in this print, right? So that's where the layer was printed. You know, the nozzle can only go so small, and then it has to push out the hot plastic to adhere to the previous layer, and then it'll cool a little bit, and then it'll print the next layer as it moves up on the z-axis, right? So it's 3 dimensions. X and Y is on the plate, and then Z is as it moves up, right? So these lines are very visible. Now, the technology has improved, and you can get very smooth miniatures with FDM printers if you tune it up just right, you really understand your material, the software you're using. But I find that's too much for me personally. And then the other problem I have personally is, as I mentioned previously, the underneath this guy's shoulders, there's nothing there. So as I'm printing, it'll be trying to print in the middle of the air because it's building this thing up from the ground. And so I don't have an editor handy, but I'd show you. But underneath his shoulders, you have to have support material. So the printer's going to print stuff that it can then build onto later on in the print. Those are supports. I'm going to show you resin supports today. I'm not going to show you supports for an FDM. But I find that the plastic, when it cools, it's difficult to remove those supports if you're printing FDM. And the other problem I run into is it leaves stuff I need to sand or smooth in some way. So if you don't orient your miniature in an easy way, then you're ruined. Like if I had this thing face down, his face would get ruined by the support material. So, and again, if you have questions, drop them in the chat. Happy to answer. Love, the interaction between you and me. So I don't like to just hear myself talk. I'm not that kind of guy. Anyway, so as you can see, if this is a miniature on the table, it would look fine. But as a miniature painter and a sculptor, I want more detail. And so the limits of the technology means I can only get so small, like 0.25, I believe is the smallest you can get today on that nozzle. And the smaller the nozzle, the more delicate the settings have to be to print successfully. Now I do print a lot on the FDM printer, just not miniatures. So I print buildings, I print scenery, and those things react really well. And if you orient the model correctly, you can even take advantage of those lines, as texture in the model. So I still use mine a lot. I have Anycubic Mega X. It's a very large print, so I can print most of the base buildings without having too much, having to chop them up into smaller parts. And I'll show you the chopping up in a minute too. So I use it all the time, and then I also use it for bases. I've got the settings tuned up for myself on that printer that I can successfully print bases that I can use on my miniatures, and it's much cheaper than the resin. So in addition to the printer itself being cheaper in most cases, the filament, that spool of filament per kilogram or whatever is going to be cheaper than resin. So that's one of the advantages of FDM. The other advantage that you might find is you're not having to deal with chemicals so much. And resin is a chemical, it's photoreactive, and it comes in bottles. And so that's going to impact. Let me get back to the website, and I think they have. Here's PLA filament, right? So it's on a spool that you buy, and then that spool just runs down as it prints. Where if you're printing with a resin printer, let's see, I'll just grab a random one. It's in a bottle, and you're pouring it into a vat, and it's printing the model out of that vat. And so you're having to deal with those chemicals. So rubber gloves or some kind of protective gloves. It's best to wear goggles and potentially a face mask, depending on how much ventilation's in your room. Now, FDM printer does have odors and stuff you have to do. So a well-ventilated room is important because you're heating the plastic, so that can generate fumes as well. And those fumes can be strong, and so that might be an issue if it's in an apartment. Feldar, you had a great question. Is there special disposal for the resin? Absolutely is, right? So resin is a toxic material in its liquid form. And so the bottles have to be gone through like a hazardous waste roundup, or you have to somehow get the resin from inside the bottle into the sun so it'll cure, and then you can throw it away. Once it's solid, it is now safe, and you can throw it in the trash. And so that really makes life complicated. And most resin also requires a post process where you have to clean it to get the extra resin off of it, and you have to use isopropyl alcohol or a similar chemical, a new chemical you have to deal with. And once it's been exposed to the resin, it is also a toxic material that you have to dispose of carefully. Now, you can recycle it to a certain extent and extend the life of that isopropyl alcohol. IPA is often called, but whenever I hear the word IPA, I think of a different liquid that you can actually imbibe if you are of a mind to. But isopropyl alcohol, you have to dispose of. Now, there are some techniques to recycle it where you filter it and let it sit in the sun, and you filter it again so you can use it over and over for a really long time. I have resin I've been recycling for a year, right? So not resin, but the isopropyl alcohol. Used resin, you just lay it in the sun, let it cure, and then you throw it in the trash. So you really need to understand what you're getting into if you buy a printer. Now, there is a new technology that's available for resin printers. So I'm kind of sidetracked by the question, but it's a great question. There is water washable resin, and I use that. on printers that support it anyway. And you can use water to clean it and to remove the excess resin from a model, which is awesome because you don't have to buy isopropyl alcohol. Now, once again, though, if the water's got resin mixed in it, you can't just pour it down the drain. That's not safe. That liquid resin in the water is a toxic material. And so you have to filter that water. And so that's what I do. I have jugs of water that I um, let it react to the sun, and so the precipitate, the resin will become solid and show up in the bottom. I can filter it out, and then after a few times, then I can put that water in the drain because there's no resin left in it. So water washable resin is better, not best, right? It's still a chemical you have to handle and be careful with. And that's what's here on my screen is water washable resin. So you don't think that you can just wash it in the sink and let the extra resin pour down the sink. That's not a safe thing to do. Um, that was FDM printers and a little bit about resin. So a resin printer you can buy from different manufacturers. So another manufacturer I've used besides Anycubic is Epax. Now, that's a really good affordable set of printers. It's a very small build plate, but for miniatures, a small build plate is really a challenge, right? So Epax is a great company to look at. They make all kinds of resins and they sell material, a really slick company. Anycubic is a good company. My favorite at the moment is Elegoo, right? So the workhorse printer I'm using right now is a Saturn II, and they even now have more advanced 3D printers. So let's see if I can get their Saturn. So I have a Saturn II, which is 12K. And so this is a little bit more about the technology. So the way resin works is it's a photosensitive resin. So that means if it's exposed to light, it goes from liquid to solid, which is the property that we're taking advantage of. So inside the printer, it just shines light on the resin to make your model. And so instead of building it, bottom layer and it growing like in an FDM printer, you're actually doing it in reverse. You do a layer and it pulls the build plate pulls away from the vat, the print, and then that LCD panel does another flash of light, and then it pulls away and another flash of light. And so LCD printers is the most common today for us at home. And I love my printer, and it's got a bigger build platform, so I can do bigger models. And after I tuned it in, it was frustrating at first, but once I got it tuned in, where it works with the resin I buy and the settings work, I get the prints I want, I can just chug through. Now, when it fails, there's a lot of work that goes into recovering from a failure, but I have fewer failures now that I've got it tuned in. And I'm going to show you guys some software here in a second. And so the Saturn is a really good brand. So Epax, Elegoo Saturn, Anycubic are all great companies that provide good products, right? So I haven't had any problems with any of those three companies for both. And then Anycubic, I have the FDM printer, and then I have the other two as resin. Now, full disclosure, my first printer was not an LCD panel, and I'm talking more about LCD panels in just a second, was actually a very expensive printer from a company called Formlabs. And let's see, I'll just do the Form 3. So I have this printer. I had the earlier model, the Form 2. I didn't get the Form 1. I wasn't into 3D printing yet. Didn't have the money either at that time. But this is really a professional printer, professional price. This is thousands of dollars. The resin is really like 4 or 5 times more expensive than other resin. But the reason I bought this and used it for so long is because almost no failures. It's a professional printer. So it really worked well for me. I still have the Form 3 up and running, and I print on it occasionally. But I've moved to the cheaper printer, cheaper resin, and having great results. So I don't miss this printer, but I wish Formlabs had stayed in the hobby space. So where they kept making professional printers for industry, like dental and other industries that use these printers all the time. I'd love for them to have continued making uh, consumer grade printers because it's such a great company. So I just wanted to share. I do have this. I have used it. A lot of my earlier miniatures were printed on this thing, and I just loved it because it was so easy to use, and I didn't have to stress so much about the settings, tuning the printer. But it is incredibly expensive. I don't want anybody to think otherwise. This thing, I think the current price is $3,000. Not many people can afford that. I saved up my pennies and I bought it. And then, but the resin's also a lot more expensive and there's more consumables. So you have to really be in it with some money. Either you make money through the service, through selling, or whatever business you're in, or you can support it independently. And I could no longer support it independently, so I got the other printers. But I did want to share that with you. The other difference here is this doesn't use an LCD panel; it actually uses a laser. And so it has mirrors and it sends a laser to one little itty bitty spot on the in the resin, and then it solidifies that spot, and then it lasers another one and another one. Then it pulls away and it does that. So you can get very accurate results with just a laser. Takes a lot more time because the LCD panel, it just shines light everywhere it needs to on that layer. Then you pull away and it shines and it does another layer. So there's even different technology in resin printing, and there's more. Like some of the new printers now can print even faster than what I can do. So I can close this one up because it keeps wanting to chat with me to make me buy something. That's another great question, Feldari. So, resolution of printers is a key component, right? So, I own a Saturn 3 12K. My ePax X1 is only a 2K printer. So, the resolution is 2,000 dots, right, per inch or whatever. You look at your resolution. It basically it's just like a television screen. 4K is high def television. Well, now there's 8K and 12K. But what impacts resolution is that's how many dots it can do on the screen. Well, the resolution of your print is also affected by the size of the build plate. If I have a big printer that's 12K, that actually might be a lower resolution than a small printer at 4K. So you really need to understand both. Um, but beyond 4K, honestly, the human eye is not going to really recognize it. I mean, you'd have to get out a magnifying glass to see the difference in the quality you can do between a 4K, an 8K, and a 12K, depending on how big the screen is. Like they make printers now that are like 4 feet by 4 feet that you can pour resin into and print. The problem with that is now that resolution is going to come down. So just be aware of that. Um, Another great question: does the resolution affect the build strength? And the answer is no. The material is going to solidify it, whatever that resolution is, and then that Z axis will pull away, and then it'll print another full layer. So if it's a solid model like a miniature, it'll be brittle, but the strength won't change. Now there are resins that give you different properties. Some of them are more flexible, and so they're not so brittle. Some of them are really, they call them tough resins, so that you can do different things. And there's a lot of amateur chemists out there. I usually just buy one resin. I don't mix them up. I buy one that's relatively affordable, and that gives me good results. As long as I don't drop it on the ground from 6 feet up, it doesn't break, or unless there's small brittle components. So even plastic miniatures and metal miniatures you were buying from the store, after you pay, if you dropped them, they'd break too. So it's not that much different. Now, when you're printing a big model, you usually want it to be hollow. And so if it's hollow, now you have to worry about the thickness that you're going to make the skin of that miniature. And so you can make it too thin and it'll become not so strong. And so you have to be careful with that. And there's limits to how thin a wall potentially could be. Yes, so tenacious would be considered a tough resin. Thank you, Shadowborn. Hey, Belinda. So the tenacious resin, its properties are for it to be really, really tough and it can stand impact. So that shear I think it's how they calculate shear. So the shear force it can handle is much, much higher. But then you have to deal with curing time, post curing, and you really need to understand the chemistry. Um, at least if you're a completist like me or someone that's very sensitive to that kind of stuff. So I don't need tenacious resin. The other thing about tenacious is it doesn't really go well with water washable. As soon as you add a tenacious resin, it's no longer water washable. You have to use isopropyl alcohol. If you're comfortable with the isopropyl alcohol process, you have a good recycling system in your garage or whatever, then there's nothing wrong with. I used isopropyl alcohol for 5 years, and you just work with it. I just prefer today. I prefer the water washable, but you can mix these tougher resins and these other resins to get properties to make your miniatures handle, you know, rough use. Like if you're playing with younger people, they may not be as careful with miniatures. And sometimes experienced players, if they're used to the Whiz Kids plastic miniatures and Reaper bones and the old pre-painted miniatures from Wizards of the Coast, they're this bendable plastic and they don't break. You can throw it across the room or whatever, and it doesn't break. So if that's the miniatures they're used to, they won't be very kind to your 3D printed miniature you set on the table. They'll grab it by the hand and toss it across the room. I've had that experience personally. So just be aware of your players may impact how fragile you let your miniatures be. Like I print very fine details where the spear isn't a big hewn piece of wood. It looks like the spear could be handled by a small person. But and I've got years of experience repairing miniatures, so it doesn't stress me as much. I used to teach how to do that at conventions, but so that all, and I can always reprint a miniature. I own a 3D printer, so breakage is not as critical for me personally. But great stuff. So let me show you some pictures just to give you an idea of what it looks like when it's printed. So this is my Saturn II, and maybe I can actually draw on this thing. Here we go. So this is the build plate. All right. So this is the part that moves up. And like I said, the advantage of this versus an FDM printer, the FDM printer has to move uh, on the x-axis or the y-axis, and it has to move on the x-axis. So the build plate moves around, and then the nozzle that's printing has to move up and down. A lot of moving parts, a lot of points of failure, a lot of wear and tear. The You have to make sure that everything's aligned and leveled and all these things. With a resin printer like this, because it's an LCD panel, all you have to align is that up and down. The z-axis. It's the only movement in the printer at all is that z-axis. I had my motor break, so it does fail sometimes. But this is the build plate, so it presses all the way down into this vat, and so the vat here at the bottom is where you put the resin, and so that build plate pushes down into the bottom till it reaches that bottom layer. It's a film, right? And then the LCD panel will flash the light for a couple of seconds. Then it'll pull away, come back down, flash a light, pull away, come back down, and it makes a miniature, right? So it's going to make it. And so there has to be supports on that miniature, like we talked about. So I'm going to show you that if I can make this advance. Oh, I'm in edit mode. I need to cancel. And so this is the build plate taken off and turned upside down. So once again, it's pulling up. So the bottom of the build plate is where it starts, and that up here is where it ends. And so these are prints with the Ruffy and the troll that we were showing the other day. And so two pieces. There's a troll on a barrel here, and there's a well. Let me edit again so you guys can see it more clearly. So here's a little bitty troll on a barrel, little baby troll. And then here's the big troll. And you can see there's these lines these are posts. They're sticking to the miniature and they're providing support so that there's something for the resin to bind to as the layers grow. And supports are one of the most important skills to learn, is the supports you need for the model and the supports you need for the resin you're using and the supports you need based on the printer you have. And I'm going to show you that in a second. But this is a complete print, and it's stuck to the build plate. So you got to use a scraper or something similar. You scrape it off the build plate or pop it off, depending on the technology that you have. But that's the next step. So, and the question is, do I use auto-generated supports? The answer is I start with auto-generated supports, right? So they're going to do a pretty good job. And then you look at the miniature and see if there's maybe a space that needs more support. And that's where the art of 3D printing comes in, because there's no science here. Because I like to orient my models a certain way so that the faces are never covered in supports, or if there's a detail I want to maintain, I want to make sure that I've oriented the model so that's not where the support's going to connect. And I'll show you guys that in just a minute. Now here's the build plate again with a close up, and you can see it was pulling these models out of the resin, and so they're done. So it starts. The bottom is the top. The top is the bottom. It's opposite day. So when you're in the software, I'll show you. You're looking at it where that build plate's the bottom, but it's really not. You have to flip it over, and that helps. You need to understand that if you have hollow product, especially. And then this is after I've removed it from the printer and cleaned it, right? So that, as you saw in the previous picture, let me go back one more. They look all, for want of a better word, they look slimy. And that's because there's uncured resin still there. It didn't drip off. It's still there. And that's why you have to clean it, either with isopropyl alcohol. There's another chemical you can use that I'm not familiar with, but I've seen it recently, people talking about it. So some jurisdictions control how you dispose of IPA, so there's alternatives, but then those have rules for disposal. So you really need to understand. Like there's twice a year in my county where I live in Oregon, they have a waste roundup that I can use. So twice a year I can take in my isopropyl alcohol or the used bottles, things like that. Now some of the manufacturers allow you to send the bottles in to be recycled, but not very many. There's only a few that'll do that. And if you live close to one of those manufacturers, it's easy. You can drive it in and do things. So there's lots of things you have to pay attention to when you're dealing with this. So this is after it's cleaned. So I've cleaned off all of that extra resin, and then in a jar it's sitting in the window so the UV light will deal with the resin that's floating in the water. The other thing that I do, I'm going to show you removing the supports, but I'm going to do another cure of the print. Even though these resins, it's not absolutely necessary, I get best results if I do another cure, and I'll talk about that too. So this is what I end up with after I cleaned it. Now I have these supports. So what you have to do is remove them. Now, one of the things you can see is I'm just using my fingers. I do that as much as I can. But I have clippers, you can see in the video too, where I can go very, very carefully if it's a sensitive part that might break, or it's around the face and I don't want to mar it by just pulling the supports away. I can clip it with the clippers. Supports, again, are a necessary evil, and but they have problems. So sometimes the supports will leave little divots in the model, or they'll leave little bits on the model. And with a file or something like that, you can clean them up. You can clean them up just like you would any other miniature. But that's the removing the supports from the big guy. And then, of course, it was a lot easier because there were fewer supports because that barrel provided a lot of support. I think I actually use the clippers on this one because my fingers are pretty big and it's a pretty small model. Now, if I was not using the water washable resin, I would still be wearing gloves. Like I said, for this printer, I've really dialed in the settings and stuff. So I have supports that come off really easy for my small prints, my regular miniatures. And so I don't have as much trouble now because of the work I've done, iteration after iteration after iteration. In fact, the supports are easier on this than on that really, really expensive Form Labs. I can't get the supports as good as I get them on here, which is why the Saturn has become my workhorse printer. Okay. Any questions? All right. So I'm going to show you. I showed the software last time because it's part of my sculpting process. This is Autodesk Mesh Mixer. You can actually use it to make models. I don't know how because I've never done it. But what I do is when I export an STL file, before I even try to print it, I'm going to use this as an analysis tool. So last time I showed you there was nothing to analyze. So I'm going to bring in a model this time that actually has some problems. So I've done everything I can in ZBrush to make this model solid. There's no problems with it where there's a little piece sticking out that can't be printed. And so it looks great, right? But it isn't great. So I can run the analysis against it. And look at that. It's finding all of these issues. Now I can repair them one at a time if I want to. But yeah, I'll get to that in a second, Feldar. Give me 1 minute. So you can see that it's found all these issues. The nice thing about Mesh Mixer is you can ask it to auto repair. And if it's successful, I'm done. I can export this now, which I've already done as the David print. And so the great news here is if it fails and there's still issues it couldn't auto repair, I have to go back to ZBrush, check that part of the model. It'll point it where the model is having a problem, and I can figure out what's going on. Maybe there's stuff pushing through. So there's points that are not printable. Like there's two, it's like shoving a piece of paper through another piece of paper. It's not physically possible. It's mathematically possible. So it can't print. And so you have to pull the paper out of the other piece of paper. It's the best way I can describe some of the problems it may not be able to fix. Or when it fixed it, it actually destroyed part of the model that I didn't want destroyed. So I have to go back and fix it in ZBrush, bring it in. But Mesh Mixer is my analysis tool. I love this thing. And it's an old version. I haven't updated it in forever, but it works really great. And I'm afraid of upgrading it now since it's tuned so well for what I do. But that's Mesh Mixer, and that's what that does. So the when you're printing, I'll show you the supports actually. So let me open up this software. So there's a couple of things you can do with supports, and one of them is a skirt. Shadowborn's right, and that's usually used for the FDM printers. And what it does is it helps calibrate. And I find the skirt is one of the most useful things I use because I hate printing on a platform, which is another thing, a raft it's called. And that's where it prints like a platform first, and then it starts printing your model. I don't love that. It uses a lot of extra material. I do platforms on my Form Labs because that was the only way to make it successful. I don't use that raft concept for resin printing on my Saturn. But the skirt on FDM printers, for some reason, it helps my prints be more reliable. But the plastic, yeah, you peel it up and I throw it away. Now, there are ways to recycle that used PLA um, plastic, but I don't recycle it. I have so little because of what I print on my FDM printer doesn't use supports. I design it so that it can be printed straight from the build plate. Um, I don't need as many supports, so I don't have a lot of extra material. So I haven't pursued the recycling stuff, but I've seen that. So this is Chitabox. It's one of the companies that allows you to create a file that can be printed on your printer. And the reason is because they make the firmware board inside the printer. So they make the software. So they tie the printers to their device. There are other packages that can create a file for that kind of circuit board. And then there's more than one circuit board. So again, that's why you have to know your printer and then learn the software that works with your printer. The other thing I can show you though, I use this for two of my printers. I have my ePacks, and the reason I'm going to show you is look how much smaller my build plate is. So if I bring up David, yeah, Lychee's a very popular one. I didn't like it personally, and I didn't love Chitabox either, but I've got it dialed in, so I'm okay with it. So let's bring in David, and it looks like he takes up a lot of this ePacks printer, and it's true. I can maybe print 2 or 3 models, or if I orient them just right, I can cram a bunch on here. But if I print it on my Saturn, you can see I could print a lot more, right? So that's the nice thing, this software can handle the different printers. And this guy on this platform, he's not printable, right? So the only thing sitting on the platform is the edge of his scabbard, right? So the rest of it's in the air. There's nothing for it to adhere to. So you have to make supports. And like I was talking about, I like to orient it manually before I make supports. So orientation is important. Again, if I rotate this dude, and if I gotta capture that green arrow as carefully as I can, and I have him face down, the supports are going to attach to his face. Well, that's the most important part of a miniature, right? Is the face. So you want to have it away from the supports. So he came in that way, which is kind of nice. I had to force it. Well, the other thing is he's got this sword, and his sword's going to be somewhat sensitive. It's pretty fragile. And so what I'm trying to do is orient it so the sword is straight up. So that no support's needed. It'll just be able to print that thing perfectly, right? And that's what I want. The rest of the model, his cloak's kind of ragged anyway, so anything the supports do will just enhance the miniature versus subtract. And then I go in here and I can tell it to generate supports. Now, there's a whole bunch of settings if you look in here. There's just all kinds of settings. That's what I'm talking about. You have to know your printer and try a lot of these different settings out. And you can see I don't have a raft. If I have a raft, it'll print a bunch of layers and it just creates this platform and then starts printing the miniature and the supports. I save material by not doing that. And so for most of the time, I don't even need to have anything more than a light support. And I look at it and you can see there might be a few other places I might want to add a support, and I can just hit the button and it'll add more supports. And then if there's a place where it's clustered a bunch, I can remove them if I need to. Like you can see it. Let me zoom in. And you can see if I just click here, it adds a support right there on his knuckle. And so I can do that. Most of the time I don't need to for my miniatures. They don't have the challenge. Now, when I was using the heavy supports, when I was first figuring out all of the settings, I had to move them around because they would be so big, they would affect the model's details. But with these light supports, I have really good luck. So I printed him out. I can show you guys pictures if you're interested in. So, and then once you have the model, right, I can actually create more, right? So with this software, I can either bring in a new model. Let's see. I think this is just a. Okay, so here's the bear, right? So I sculpted the bear. I've shown you guys pictures of this too. So I can orient this, and now I can print him too. Let's do it this way. And then I make my supports, auto-generate them. Oh, didn't realize I wanted to do it for the bear. And I think I'm going to want to do more on that arm. So one of the things you can learn is you can print at angles, right? So it doesn't need support if there's something close to supporting it. And 45 degrees is probably a little too steep. And so something less than than 45 degrees, it'll be able to print without a support. But if I'm like this fur, it's not going to be harmed too much by supports. So I might want to put some extra stuff on the arms just to guarantee a successful print. And it's just something that you learn as you're printing what to do. Does more space, more need for support. So again, it's about the angles, right? So Belinda's asking if there need more. So this angle is less than 45 degrees, so it doesn't think it needs support. So if it was a flat plane, it would have to support the whole thing. That's why if you're printing something flat, like I have a base, I'm going to have to find it. I like to think I'm organized, but I can't guarantee that I am. Not there. Where did I put it? I'll just use a regular base. So you can see, I could print this directly on on the platform, right? So if I just rotate this 90 degrees, it'll print flat, no support needed. Now, some challenges with some printers is it'll just adhere to the plate, and to get it off the build plate, you actually damage the resin, right? So you have to be careful when you do that. So most of us don't do that unless the bottom you can pop it off easily, or if you have a flexible plate that you can, like with that's connected with magnets, that you can flex, then you can print more on the build plate successfully. So I turn it at an angle. Well, what I found is if I angle it just so, we'll say that's good. The detail's on one side. And so if I make supports here, it didn't need very many supports at all. I often add a few on each side just to be safe, right? So like I said, my supports, very little touching on the model itself, so more can be better. But everybody has a personal view on how to do supports the best. But this would be printed successfully. Sometimes I tilt it a little more because this bottom of the base just sits. It's the base. It just sits on the ground. Nobody sees it. You could put some on the back here and have it tilted more, and provide more support to the model if you wanted to. Um, so the danger is really a flat plane for trying to support that. Like if this was two pieces and one straight up and one's perpendicular, you have to support that entire perpendicular plane. So most of us would rotate it in such a way that I didn't have to worry about it so much. I don't have a sample of that right this minute. Um, I wanted to show you something else real quick. Let me get these off the build plate since I don't need to print them. Oh, I want to change to the other printer. So the printer dimensions are really important, right? So we talked about this last week, right? So you need to know how, what you can print on here. So if I go back to my working documents, I've got this brontosaurus I made. And so let's just look at the torso. Let me zoom out. I cannot print this model on this printer. There's no way for me to rotate it that'll fit because it's just so big. And so what I would have to do if this was my only printer is cut it again. So maybe cut it down the middle so there's a left and a right side. Right? The good news for me is that I own a bigger printer. And so now all I really need to do is rotate it so I can print it safely and build the supports. Now, as I mentioned earlier, this model is hollow. So there's holes in it, and you can see if I zoom in. Actually, let me show you another way. So you can see it's hollow, right? And there's a hole there for it to drain, and there's a hole there it can drain, right? Well, where I currently have it situated, does anybody see a problem with this printing? Based on everything you've learned, it's quiz time. Well, of course, without supports, it's not going to print. There's some overhangs. The real problem, the holes are at the top. Very good, Shadowborn. So again, I showed you there's holes here. Well, when this thing prints, it doesn't print like this. It prints like this. So why is that a problem? Well, all that liquid resin that is going to be sitting inside this model. Right? So yes, I have to make supports. So let's really quickly make supports so everybody understands. I can't print it without the supports, right? So now I have supports, but I still have that same problem. It's going to fill with liquid resin that's not cured. What am I going to do with that? That's going to be nasty, right? So I've got to rotate it another way so that that's no longer true. So it really doesn't matter. Yes, remove the supports. Okay, now I have a second problem. And that is how I angle it matters. Let me turn it back to where it was. So if I move down, I have this foot. Now, is that foot going to fill with resin? Maybe. Is that foot going to fill with resin? Maybe. And then is one end of this model going to fill with resin? And so I think it's safest if I rotate it so that the feet are pointing towards the base. See if I can get it to, there we go. Right? So there is still going to be a small place where some of the liquid resin will accumulate here. That's called cupping, and you're basically filling a cup with resin that's uncured. But I printed it, and it's a really small amount, and that's what the two holes are for. You can rinse it from the inside and drain it out. Now, what I could have done, since this has blank space on both sides, I could put drain holes on both sides, which if I were to print it again, I would probably do that. And yeah, you could potentially put it on its back, but really you want to see where the holes are so that they drain as it's printing. That's really the most important thing. If this was a solid piece, doesn't matter. You want to look at how this is going to print. So once again, you'd want to have the parts of the model that don't matter as much have the supports on them. So if I do the supports now, I mean, you might have some issues um, with removing the supports, might leave some marks. It's a dinosaur and everything like that, so it's not that big of a deal. One of the things I wanted to show you that I wasn't able to explain as well, it'll make support between the model and another piece if it needs to. So again, if there's an overhang or something, it can't print when there's a gap, right? The air can't exist. It has to have something to connect to. So most of the software will allow you to actually put supports between parts of the model. And so you just have to remember to remove them at the end. And that's sometimes the most difficult. And so it's actually printing supports. I don't know if you can see inside this model. I'm never going to remove them. They just stay inside. It's just the cost of doing the model this way. But you still save a ton of resin when you have a big model. And you can see kind of how big this really is. If I bring up the David model again, I could have left it on there. So this is human, right? Let me rotate him if it'll let me. He'll be upside down. So that's his size compared to the torso of the Brontosaurus, right? So this is going to be, it's the biggest miniature I've sculpted and tried to print. And I had to cut it into 4 pieces. And I have another design I want to do with the same concept. Um, but I printed the basic Brontosaurus first just to see if it worked. And it took a day to print the neck and head, a day to print the torso. That's after modeling, cutting it up, making the pegs and the holes so that you can put it together, making it hollow. That all, I didn't even track the time. But this took a day, and then I have to do the back torso part, and that'll take a day, and then the tail will take another day. So just to print this Brontosaurus is 4 days. That's a great question. So you can, some people have UV strands that they could run inside the model. You'd have to drill holes so you could do that. Or if you have like a UV flashlight, you can shine it in there. So some resins that would be necessary. For these basic resins, it's not. So I once it's completely clean, I cure it from the outside basically, and there's no stress from the inside because there's holes and there's a hollow space. If this was a solid miniature this big, you might it actually could crack over time if it's not cured all the way through on the inside. It'll break. But since you have a way to relieve all that pressure, you shouldn't have a problem with it. But to be completely safe, it would be best to cure it on the inside. If this was, let's just say this was a lamp, I would definitely make the hole really big, and so you could cure it on the inside because it's going to be seeing regular use, and you don't know who's going to have it in the future, kind of thing. If you're mounting it to a piece of wood and then running a light fixture, then you wouldn't have to stress so much about it. But it really does depend on the kind of resin you're using, whether you have to stress about curing the inside and getting the technology to do that. I don't have the ability to cure it on the inside. I have a curing station that just rotates. It's from any cubic. So, and that's the other thing I was going to talk about for 3D printing, which is after you print it, remove the supports, clean it. I actually put it in a UV tower, and UV is basically the type of light. So it's ultraviolet light, and you have a cover that protects your eyes and everything, and then it just cures the outside of it a second time. Some products, some resin chemicals require that you do that post curing. This doesn't, but I still find it's a useful step to do the post curing. And goodness gracious, we're already at the top of the hour. I think that's all I needed to show on supports. Any questions? And as you can see, I really only did an overview of 3D printing. There's still tons to cover. If people have questions, I'm happy to answer them either on Discord, in Facebook. We could have another stream talking about specifics, maybe just about FDM or just about resin, etc. So, or we could even bring on a guest that knows more about the chemical stuff around the resins or the different kinds of filament. Happy to do that. And speaking of guests, next week we have Adam Eason as a guest on the show, and he's going to be talking about world building and how to do that, and his approach and process around that. So stay tuned. Come join us again next week. It's going to be a great show. And Shadowborn had a final question. What resin? I use Elegoo's water washable resin. I generally use gray, but in my e-packs, I use translucent green because I print a lot of gooey cubes. And so I use that green a lot when I'm printing. All right. So thanks, Lady Hawk. I appreciate that. I do want people to know what they're getting into. So I certainly want to cover all that. I was going through nitrile gloves like crazy. I just went to the store in the kitchen section and bought heavy duty cleaning gloves. And that's what I wear now. I can slide them on and off since I'm using that water washable resin and I'm not burning through gloves so much. I don't wear goggles, and I have a very well ventilated room, so I probably should, but it really depends on who's using the material, and if you're working with young people, safety first, and so you definitely handle it differently. Okay, I think we're going to call that good for the day. And I'm thankful for all of you that joined us. We will be posting this in YouTube. There's the GUI community channel in YouTube where you can see all these episodes and all the other wonderful things the GUI community is doing, live streams for their games and other content. So we're really trying to centralize all of this stuff for everybody. So I hope you guys have a great evening, and we're going to call that good for the day.